It's 3:47 a.m. in Russia, and something unthinkable is unfolding. Four fast-moving objects are racing toward Moscow at 380 km/h, completely invisible to one of the most advanced air defense systems on Earth. They shouldn't even exist. At an S-400 radar station outside Ryazan, an operator stared at his screen. The contacts looked like a flock of birds, except birds don't fly in perfect formation. And they definitely don't head straight for Russia's largest oil refinery. At 52 kilometers from the target, just 27 kilometers from the S-400 battery, the lead Beaver drone suddenly climbed to 800 meters. The missile would need 27 seconds to reach them. The drones, at emergency power, could reach the 2-kilometer dead zone in 41 seconds. That gave the commander just 14 seconds to decide, real targets or decoys. Each missile cost $2 million. 10 seconds. The contacts were closing fast. 7 seconds. His training said, wait for confirmation. 5 seconds. But if they were real, he had to act. Two 48N6DM interceptors roared into the sky, accelerating to Mach 6 in 3 seconds. Then the drones dove, back down to 200 meters, vanishing below the radar horizon. Here's the problem. Those missiles use semi-active radar homing. They don't have onboard radar. They rely entirely on the ground radar's paint to guide them. Without that signal, they're blind. The commander watched in disbelief as the missiles tried to guess the target's path. Their computers had only the last known position. They exploded 80 meters above where the drones had been, 24,000 steel fragments tearing through empty air. Now, the refinery's last defense, 2 Panzer S-1 batteries, had 17 seconds to respond. But their radars were designed for aircraft, not tiny drones. Against a 0.1 M2 target at 8 km, the return signal was barely above background noise. 12 seconds. Blips flickered on and off. 8 seconds. The operators tried to slew the 30mm cannons, but the turret takes 3.2 seconds to rotate 180 degrees. 4 seconds, the lead Beaver locked on. At 3:52:17 a.m., the first explosion hit, and that was only the beginning. 3 more Beavers struck 3 more targets. The chain reaction ignited 140,000 tons of petroleum. Within 90 seconds, the western section was a 200-degree Celsius inferno that burned for 72 hours. Moscow's fuel supply was slashed by 40%, but it wasn't over. 470 kilometers away, 12 more drones were closing in. And this time, the Russians thought they were ready. At Noble Quivist Refinery, 3 Panzer S-1 batteries stood guard in a triangle formation, overlapping fields of fire. Each radar could track 20 targets and engage 4 at once up to 20 kilometers away. They'd studied Ukrainian tactics. They believed no drone would get through. Then, at 4:03 a.m., something strange happened. 4 of the 12 drones suddenly climbed to 500 meters. Their radar signatures shifted. Speed, shape, frequency. Everything now matched KH-101 cruise missiles. In reality, they'd deployed corner reflectors, tiny aluminum triangles that bounce radar energy straight back, creating a massive false signature. A 10-centimeter reflector can mimic a 10-meter target. The radar thought it was seeing cruise missiles, exactly as intended. The commander had 2 seconds to choose. Cruise missiles are always top priority. He launched 8 57E6 missiles in 12 seconds, each screaming skyward at 300 ms. But something didn't add up. These cruise missiles were pulling 9G turns, impossible for a KH-101. Then they began multiplying. 4, then 8, then 16. What was really happening? Each drone was dropping new reflectors every 2 seconds, creating phantom targets. $3 million worth of missiles chased bits of aluminum foil that cost less than a cup of coffee. Meanwhile, the real attack was coming from behind. While the defenders watched the decoys high above, 8 UJ-22 drones skimmed in from the opposite direction, just 50 meters above the ground. The Panzer's biggest flaw? Its radar can only steer 45 degrees electronically. To look behind, it must rotate the entire 3,000 kilo turret. A 4.7-second maneuver. Traverse now. The commander yelled, too late. The drones were already inside 1.2 kilometers. At that range, the missiles were useless. They need 1.5 seconds to arm their fuses. Only the twin 30mm cannons could respond. Both guns opened fire, 5,000 rounds per minute. The computer calculated the lead angle, 31 meters for a target crossing at 200 km/h. But the UJ-22s were ready for this. Every 2 seconds, they randomly changed altitude between 40 and 80 meters. The Pantsir's predictive targeting turned into guesswork. The hit probability dropped from 83% to 31%. One drone disintegrated in the gunfire, but 7 broke through. 3 hit their mark. As the smoke cleared, all 3 Pantsir batteries were reloading. Their 57 E6 missiles had to be reloaded manually, a 90-second process of total vulnerability, and that's when the third wave struck. The refinery was hit again. Every move, every second, had been calculated to perfection. At the next target, Russia had moved something the Ukrainians hadn't caught. At 04:18, 6 UJ-26 Beavers approaching Vannes suddenly went blind, GPS gone, comms dead, navigation screens static. A Krasuka 4 electronic warfare vehicle had just switched on, and this wasn't ordinary jamming. The Krasuka 4 blankets 0.118 GHz with 500 watts of directed power. By comparison, GPS signals arrive from satellites 20,000 km away at about 0.025 watts. The Krasuka's signal is essentially trillions of times stronger, like trying to hear a whisper inside a jet engine. The drones fell back to inertial navigation. But their gyros drift 10 degrees after 380 kilometers in 68 minutes, which can mean 200-meter misses, mission failure. The lead drone went into crisis mode. At 95 degrees C, the processor began thermal throttling, slowing pattern matches. It started load shedding, nav lights off, telemetry off, radar warning receiver off. Each watt saved cooled the processor a fraction and bought processing speed. 30 seconds to impact. Still no fix. The algorithm was failing. At 20 seconds, the processor hit 98 degrees. 10 seconds, thermal shutdown looming. 8 seconds, the pattern locked. Not on the tanks themselves. Their shadows were useless. But 3 tanks formed a stable geometric relationship. The intersection of their shadows made a triangle with fixed angles. Tank 7 was identified with a 4-meter margin. The fix, however, was trapped in one drone. Jamming had severed links. The lead Beaver needed a desperate move. It used frequency-hopping spread spectrum, leaping across 1,000 frequencies per second. The Krasuka can't jam every frequency equally. On channel 847, for 1 microsecond, a gap opened. The drone pushed 128 bytes, just coordinates and impact timing. The other 5 drones picked up the fragment via match filtering and adjusted course. Tank 7 took the first hit at 04:20. The warhead struck where steel met concrete, the weakest point from differential thermal expansion. A fuel lake ignited. The Pursuit 4 crew watched a wall of fire at 30 memoras and abandoned their $20 million vehicle. As jamming cleared, 8 more drones appeared on radar, heading for Russia's most heavily defended military target. Primorsko-Akhtar airfield was a fortress. 4 Torum-2 air defense vehicles in a diamond with 5-kilometer spacing. Overlapping coverage. 2 Su-35s circling at $8,000 m. Every radar and fire control system active. 8 drones should have been a guaranteed shoot-down, but the Ukrainians exploited behavior modeling. The 8 UJ-22s didn't fly straight. They wove in a sinusoidal snake pattern. That costs about 8% extra distance and fuel, heavy for a one-way mission, but it defeats command-guided intercepts. Tor-M2 fire control assumes predictable motion. Random weaving injects process noise and compounds error. By missile launch, the predicted intercept point could be off by 50 met at 04:32 exactly. All 4 Tor-M2s fired. 16 938 missiles accelerating to Mach 2.5 with solid rockets, using 3-stage guidance, inertial, then command guidance, then active radar terminal homing. 10 seconds to impact. The seekers locked, then the unexpected. The UJ-22s pulled a 6G vertical, climbing from 180 meters to 200 meters in 4 seconds. The missiles, using canard control, couldn't sustain that angle. The canards stalled above about 12 degrees of compensation. Most missiles flew below harmlessly, except one. Its proximity fuse registered an infrared signature above. The drone's 180-degree exhaust at 400 degrees C. The warhead detonated, spraying 3,500 tungsten cubes. The drone disintegrated. That spectacular interception served its purpose. Every eye, every radar, every weapon looked up. Nobody saw what came from the sea. 15 seconds later, 4 UJ-26 Beavers crossed the beach, having flown 700 kilometers over the Sea of Azov at 5 meters altitude. For 2 hours, they used radar altimeters to hug the waves. Seawater reflections required constant recalibration. But the sea route meant 0 ground radar. The horizon at 5M is only 18 motor. The Shahed storage hangars were undefended. Inside Hangar 2, 30 Shahed 136s sat in maintenance cradles, each with roughly 40 kilos of explosive and 50 L of fuel. That's about 200 kilo of explosive and 1/500 L of fuel across the hangars.